All right, in this lesson, 9.1, we're solving trigonometric functions graphically and with a unit circle, so make sure you have all of your tools ready. Let's look at the first problem together. And, as always, when we learn mathematics, we're very active in our thinking. So I'm going to invite you to pause the video to attempt this problem before watching the solution. Attempt this first. How many solutions do you expect the equation cosine of t equals 1/2 has? Find them. Well, knowing that we have our tools of the unit circle, I'm going to start there. When I think about cosine, I think about the x value of my ordered pair. And I know that the x value of my ordered pair has a solution cosine t equals 1/2 at a couple different places. Specifically, right here, 1/2, and any other places? Symmetry of the circle. I know that that x value is the same anywhere on this line, so I can draw them. X is 1/2. X is 1/2. This unit circle actually looks a little bit off. Because the x value is 1/2 anywhere here, halfway between 0 and 1. This length is 1, so my x is 1/2, right? This length is 1, so from here to here, I have 1/2, which means the x value, or cosine of that angle, is equal to 1/2. We know that that angle is pi thirds, or 60 degrees. Likewise, we can talk about the reference angle, or we can swing all the way around the unit circle and know that that is 5 pi thirds, or 300 degrees. So cosine of 300 degrees is also 1/2. So our solution to this initial warm-up problem, we should have expected that cosine of t has two solutions, one at pi thirds and one at 5 pi thirds. Equivalently, those are in radians, I have 60 degrees and I have 300 degrees. Now, this expectation could be informed by the unit circle, but what we're learning in section 9.1 is that we can use the unit circle. We can also use graphical representations. So like we've seen before, we can think about cosine of t equals 1/2. These are the values that make this equation true. We can also think graphically. When we think graphically, we're comparing two functions, y1 and y2, or f of t and g of t, and we can graph those using our graphing calculator. So solving the same problem in two different ways helps support our understanding and representational fluency. Cosine of x, close parentheses, and I'm looking when it equals 1/2 or 0.5. I'm going to check my degree mode, or my mode, excuse me. Right now I'm in degree mode, so I should expect those two solutions. I always check my window. Right now I have 0 to 2 pi, 1 revolution. Every pi halves, -1 to 1, that's fine. So when I look at my graph, something is wrong. Oh, I know. My window is set in radian mode, yet in my mode I'm in degree mode. So I'm going to change to radian mode and get a better graph. There's my cosine curve and the value of x equals 1/2. So if I were to trace at these values of pi thirds, they intersect at an x value of pi thirds and a y value of 0.5. Likewise, I can trace at 5 pi thirds, x value of 5 pi thirds, y value of 0.5. I can do the same thing in degree mode. So I could sketch a little graph, -1 to 1, I know that's my cosine curve, right? So I have this nice graphical representation. At 0, my cosine is 1. At pi halves, it's 0. I get to my minimum and back up at my maximum at 2 pi. 2 pi, I get -1 at pi, and I get zeros at pi halves and 3 pi halves. Because in my mind, I'm envisioning my unit circle, right? I'm envisioning my unit circle. So here we had a solution on our unit circle where we had these two values, half. There are angles, that angle, and that angle, and graphically we can see our solutions here having the same values. Excellent. We're really learning.